Welcome back to For the Mariners by the Mariners channel. As the maritime industry shifts toward electrification and decarbonization, the permanent magnet synchronous motor, or PMSM, has emerged as a critical technology for modern ship propulsion and auxiliary systems. Unlike traditional induction motors, which rely on induced currents in the rotor to create a magnetic field, the PMSM utilizes powerful permanent magnets integrated directly into the rotor structure. This fundamental design difference eliminates rotor copper losses and significantly improves the overall efficiency of the vessel, especially at partial loads. When designing a PMSM for marine applications, engineers must prioritize power density and thermal management because engine room space is always at a premium and high temperatures can demagnetize the rotor. The stator of a PMSM is typically wound with high-quality copper coils that produce a rotating magnetic field when energized by a variable frequency drive. The rotor magnets lock into sync with this rotating field, ensuring the motor runs at exactly the synchronous speed, regardless of the torque demand. For large-scale ship propulsion, these motors are often designed with liquid cooling jackets or internal air-to-water heat exchangers to dissipate the heat generated during continuous operation. Maintenance of these advanced machines requires a different mindset compared to conventional equipment. Since the rotor is always magnetic, even when the power is disconnected, safety protocols are paramount to prevent accidents during disassembly. One of the most important maintenance tasks is monitoring the integrity of the winding insulation through regular polarization index and insulation resistance tests. Because these motors are often driven by pulse width modulation from a frequency converter, high voltage spikes can stress the insulation over time. Bearing maintenance is also crucial, especially in a marine environment where vibration and hull deflections can lead to misalignment. Technicians should use laser alignment tools to ensure the motor shaft is perfectly centered with the load to prevent uneven wear on the bearings and seals. Another vital aspect of maintenance is checking the cooling system for leaks or blockages, as a failure in cooling can lead to a rapid rise in internal temperature, which might permanently damage the permanent magnets. If the magnets reach their Curie temperature, they lose their magnetic properties and the motor loses its ability to produce torque. Modern PMSM systems often include embedded thermal sensors and vibration probes that provide real-time data to the ship diagnostic system, allowing for a condition-based maintenance approach rather than just relying on fixed intervals. If you found this video helpful, please give us a thumbs up, hit the notification bell, comment, like, share, and subscribe for more insights. Thank you.